Hi there, this lesson is on equations of lines, and specifically we're going to be writing the equations of lines. So with an equation of lines, there's actually three forms of an equation for a linear line. So there's slope-intercept form, and this is your y equals mx plus b, which is probably the most common form of a line when we think of the equation of a linear line. So for this you're going to need a slope and the y-intercept. So slope is represented by the m, and your y-intercept is 0, b, that point. And this is really great for graphing. And like I said, it's probably the most common form of the equation of a line. Another form of an equation of a line would be the point-slope form. And this does not look as pretty and compact as slope-intercept form, but it's actually really useful. So what it is, it's y minus the y coordinate of a point equals m, the slope, times x minus the x coordinate of that point. So you're going to need the point on the line, which is x1 comma y1, and the slope m. And this is a really great form of the equation of a line because it's pretty easy for writing the equations and there's not a lot of steps. It's made for this stuff. And the third form of the equation of a line is what's called standard form, and this is ax plus by equals c. And you find this a lot more when you're writing equations to model real life situations, but it's generally not very useful. There's nothing you can pull from this right by looking. Like slope-intercept form, you can find the slope and the y-intercept. And point-slope form, you can find that slope and a point on the line. But standard form requires you to manipulate and change it in order to find out some information about that line. So today we're going to be focusing on point-slope form because we're going to be writing equations of lines. So here in our first example, we want to write the equation of a line with a slope m equals 4, and it goes to the point 2 comma negative 5. And we're going to take this and put it in point-slope form, and then we're going to give our final answer in slope-intercept form, the y equals mx plus b. So to start, we want to use point-slope form. Y minus y1 equals m times x minus x1. So we have our m, or our slope, right here, and then the coordinate point is our x1, y1 values. So I'm just going to take these three values and plug them into my equation in their appropriate spots. So that would be the equation of our line, but we want it to be in slope-intercept form when we finish. So what we're going to do is, the first thing on the left here, I have minus and negative, so I'm going to take those and make them into a positive. So y plus 5 equals, and on the right side, I'm going to take my 4 and I'm going to distribute it through that parentheses. So 4 to both of those values. So 4x minus, and 4 times 2 is 8. Now, we want to get y by itself because remember, slope-intercept form is y equals mx plus b. So the whole goal is to get y all by itself. So in my equation here, what I have, I need to move the 5 to the other side. So I'm going to subtract 5 on each side. So y equals 4x, and negative 8 minus 5 would be minus 13. And this would be our slope-intercept form for the equation of the line with a slope of 4 and going through the point 2 comma negative 5. So we'll do another example here. This time we're writing the equation of a line where the slope m has a value of negative 2/3, and it goes to the point negative 9 comma 2. And again, we're going to put our final answer in slope-intercept form. So let's start off with point slope. Y minus y1 equals m times x minus x1. So our m is labeled for us. It's the slope right here. And our coordinate point is x1 comma y1. So we're going to take those three values and plug them in. So y minus, and my y1 value is 2, equals m, slope is negative 2/3, and then x minus my x value is negative 9. So before I do anything here, I want to rewrite this so I don't have that double negative in the parentheses there. So the left side stays the same in this case, and I still have negative 2/3 on the outside. But the inside, instead of x minus negative 9, now becomes x plus 9. So now we're going to go through that same process, and we're going to distribute this through my parentheses here. Y minus 2 equals, so negative 2/3 times x is going to stay negative 2/3 with an x. And now we have negative 2/3 times 9. When we multiply fractions, it's actually a lot easier if you write both values as a fraction. So what we're going to do is go negative 2/3 times 9/1. Because any whole number, you can write it with a denominator of 1 without changing the value of that number. And when you do this, what it allows you to do is when you multiply fractions, you're just going to multiply straight across the top and straight across the bottom. So negative 2 times 9 equals negative 18, and then go across the bottom and you get a 3. 3 times 1 is just 3. And now you can reduce that fraction. So negative 18 divided by 3 is negative 6. So remember, this all comes over here. That was this whole part right here, this negative 2/3 times 9. That's what we were trying to do there. And now what we're going to do is we want to get y by itself. So we're going to go plus 2 and plus 2. So y equals negative 2/3 x. And negative 6 plus 2 would be negative 4. And that would be the slope-intercept form. So I'm going to box that in for my final answer. So the slope-intercept form, where the slope is negative 2/3 and it goes to the point negative 9 comma 2, is this equation here. Y equals negative 2/3 x minus 4. Okay, so here's a problem for you to try. It has all the values here, and I'll just kind of identify them for you to help you stay a little bit on track. And I'll also write our point slope form out for you. So I want you to go ahead and pause this video and take the time and plug in the values and do the math yourself, okay? So hit pause and we'll come back here in just a second. Okay, so welcome back. I hope that you were able to feel a little bit successful in doing this problem and confident. So let's go ahead and check your work. So the first thing we're going to do is plug in the m, x1, and y1. So y minus negative 1 equals negative 3 times x minus 8. And those are just the values there that we've already identified. So this double negative on the left, we're going to rewrite as y plus 1 equals, and then on the right, we're going to distribute this negative 3. So negative 3x plus 24. And the last step to get y by itself into slope-intercept form would be to subtract 1 from each side. So y equals negative 3x plus 23. And that there would be our final answer for this problem. So the other thing that we can do with point-slope form is we can find the equation of a line that goes through 2 points that are on that line. But point-slope form, remember, you need a single point and a slope. So when you're given 2 points, the first thing you need to do is find the slope. So first, find slope. Remember, slope is rise over run, or in other words, your change in y over your change in x. So to do this, what I'm going to do is I'm going to go ahead and I'm going to put these into a table actually. So 2, negative 1, and negative 2, 7. And I'm going to see what's the difference from one point to the next point. So 2 to negative 2 here. To go from positive 2 to negative 2, I'm going to subtract 4. And to go to do the same thing on the y's, to go from negative 1 to positive 7, I need to add 8. So if I go back up here to my slope, rise over run, my change in y would be plus 8 over the change in x, which is minus 4. So positive 8 over negative 4 is just a negative 2. And so that would be my slope. Now that we have our slope, we can write the equation of our line in point-slope form. And probably the most difficult part about this is accepting that you just have to pick a point. There's not a right or a wrong point to choose. You just need to pick one. So I personally tend to choose the first point. So I'm going to use this as my x1 and y1. So y minus y1 equals m times x minus x1. So now I'm going to go ahead and plug those values in. Y minus, and y1 is negative 1, and my slope is negative 2, because we just found that over here on the left. And then x minus x1 is a positive 2. So on the left, I want to take these negatives and make it positive, because it's a double negative. And on the right, I'm going to distribute that negative 2. So it becomes negative 2x. And then a negative 2 times a negative 2 is plus 4. And the last thing we want to do is we want to subtract the 1 on both sides, because on the left side we only want that y value left. So subtract 1. So y equals negative 2x, and positive 4 minus 1 would give us a positive 3. So this equation, y equals negative 2x plus 3, it goes through both points, 2 comma negative 1 and negative 2 comma 7. Okay, so let's do another one just to make sure we kind of have our feet grounded in this idea of finding the slope and using it for point-slope form. So the first thing is we need to find our slope. Find slope. So slope is the rise over run, but we know that rise means up and down, so that's the change in y over our run, which is right and left, so that would be the change in my x values. And if you know the slope formula, you can absolutely use the slope formula. I just choose not to. I like my tables because I like looking for patterns personally. It just really clicks for me. So negative 5 and negative 2, and then 1 and negative 8. So from negative 5 to positive 1 is plus 6. And then from negative 2 to negative 8 is a minus 6. So my slope would be the change in y, so negative 6, over my change in x, positive 6. Negative 6 over positive 6 is a negative 1. So now we have the slope, and now we just need to use one of my points to use point and slope form. I always just choose the first one. There's no rhyme or reason for it. You can use the second one if you prefer. Okay. So y minus y1 equals m times x minus x1. And I'm going to plug in these values now. So y minus, and my y1 in this case is negative 2, equals m, which is negative 1, times x minus, and my x1 is negative 5. So first thing, I'm going to go through and take all these double negatives and make them positive just to clean this up a little bit. So my left side is y plus 2, and my right side is still negative 1, and then it becomes x plus 5 in those parentheses. And now I can go ahead and distribute this negative 1 on the front. So y plus 2 on the left, and this becomes negative x minus 5. And then I just need to subtract 2 to get y by itself. So y equals negative x, and negative 5 minus 2 is minus 7. So this equation in slope-intercept form would go through the points negative 5, 2, and 1, negative 8. So here's a problem for you to try. So remember, you first need to find your slope. Okay. And you can use the slope formula, or you can use a table. And once you find your slope, you're going to use your point slope form. To write the equation of your line. So hit pause on this video, give it a try, go back to the problems, use that as a reference, and we'll come back and we'll finish it off together, okay? Okay, so we're looking for slope. So to find our slope, it's the rise over run. And as we've talked about, that's the change in our y values over the change in the x values, or the difference in the two. So I'm going to put these into a table. 1 to 7 is a plus 6, and 2 to 5 is a plus 3. So my slope, change in y plus 3 over my change in x plus 6. And so 3 over 6 equals 1/2. Now I'm going to go over here, and I'm going to use my first point as my x1 and y1. And I'm going to plug my slope and my point into this equation. So y minus y1 is 2, equals my slope, 1/2, times x minus x1, which is 1. So first thing I'm going to do is go ahead and distribute this through my parentheses. And that becomes 1/2 x minus 1/2. And now I'm going to go ahead and add 2 to each side so I can get y by itself, so I'm in slope-intercept form. So y equals 1/2 x. And now we have this negative 1/2 plus 2. So to add fractions, we need to have the same denominators. So this would be negative 1/2 plus, and this would be 2 over 1. But we want to change the 2 over 1 to something that has a 2 on the bottom. So I need to multiply both of these by 2. So I get negative 1/2 plus 4 over 2. Notice how 4 over 2 would reduce down to just a 2. So all we did was change what that looked like. And now I can just add the top numbers. So negative 1 plus 4 would be 3, and your denominator stays the same. So when you're adding, you only change that top number. And this 3/2 is what's going to go in to my equation. And this here would be my equation. When we're writing equations, we're going to be using point-slope form. And so to do that, you need to first find your slope. Either it's going to be given to you and it will tell you that here's your slope, or you're going to need to find that slope from 2 points. Okay. And then after you have your slope, you're going to plug the slope and that point into your point-slope form here. If you're given 2 points, you can pick either point. Again, I tend to pick the first point, but you can use the first point or the second point. And once you plug that slope and those 2 points in, you're just going to solve for y. Okay? So find your slope, plug a slope and a point in, and then solve for y. And that's all you had to do to write the equation of a line.